Hello, everyone. In this video, we'll talk about modeling approximately normal distributions. So if you're given a data set and you believe it to be an approximately normal distribution, you may look for some basic statistics to try to then extrapolate what other statistics are uh, assuming this normality condition. So I'll give a single example, but you can look in the text for some more examples of this type of a scenario. So let's suppose we're interested in the data set of adult weight in the US. So we're looking at adult weight in the United States. And we know a couple of things. So we know, although this data is really approximate and not completely known, so let's just make the assumptions. So we know that the average is, let's say, 200 pounds. Just it's close to this, but it's not exactly that. And the first quartile, Q1, is 150 pounds. Um, so we want to assume, so we're going to assume or model. I mean, it's definitely not the case, but we are using a mathematical model. Adult weight in the US as a normal distribution, an approximately normal distribution. So we can then ask some other questions, but in order to answer them, we need basically two bits of information. So to use this model, you will need two bits of information, typically. And this is sort of almost always you need these two bits of information. You need one, the mean, and two, the standard deviation. So many of the formulas that we use or we see with normal distribution contain these two numbers. Okay, so in this case, we are given the mean. So here, this case, we have mu is equal to 200. That's the average. However, we are not given the standard deviation, but we can use our formula for the first quartile in a standard normal distribution to calculate the standard deviation. So to find sigma, use this formula that Q1 is equal to mu minus 0.675 times sigma. Now, how are we going to use it? You have to look and see what is given. We're given Q1. We know mu. We need to find sigma. So let's go ahead and put in the values. We have 150 is equal to 200 minus 0.675 sigma. Now we can subtract 150 from both sides, and we can add 0.675 times sigma to both sides. We get this equation. If you divide by 0.675, you will get an approximation of this, which is around 74 pounds. just leave 74. Okay, so now we have the two things we need. We have our mu and we have our sigma. And from this, we can calculate several other quantities based on our assumption that we have an approximately normal distribution. So we can calculate like the 2.5th percentile. I mean, we can calculate several percentiles. We can calculate P 2.5. This is equal to mu minus 2 times, this is 2 standard deviations before the average. So this is equal to our average, which is 200, minus 74 times 2 is 148, which is equal to 52 pounds. So that's a very low weight, but the 2.5th percentile is pretty low. You can calculate the 16th percentile and the 84th percentile. These are all just calculated by similar, because these are the one standard deviation away from the mean, both before and after. So this is mu minus sigma. This is mu plus sigma. And so 200 minus 74 is 126 pounds. And, well, 200 plus 74 is not too hard to calculate, 274 pounds. So you see that some of the basic things, some of the basic statistics that you would want to calculate maybe can be pulled from just the assumption really of an approximately standard normal distribution. Now, again, the things you need are the mean and the standard deviation in order to calculate these. And of course, you could calculate the third quartile. In this case, that would be 250, and a few other things. So I'll leave those computations and exercises to the reading, but this is the idea of modeling with standard normal distributions.